All right, explorers, and welcome. Think of this as your official science exam field guide. I'm your guide for this expedition, and we're about to get you geared up for your next big adventure. Yep, you heard me right. Your next big science mission is that exam coming up. But we're not going to think of it as just a test. No way. It's a mission. It's your chance to show everyone what you've discovered, to map out everything you know, and prove you've got what it takes. I knew you would be. Look, every great explorer needs a field guide, right? And that's exactly what we're putting together today. This is going to help you navigate the terrain of your exam, spot those key concepts, and record your findings like a total pro. So let's dive in. Okay, first things first, we've got to understand the world we're exploring, and that is the world of matter. I mean, literally everything you can see and touch. It's all matter, and it mostly comes in three main states. So let's start with a solid. Picture a rock you find out in the field. You can pick it up, you can put it in your pocket, but it's always going to be a rock, right? It keeps its shape, it keeps its size. That's because all its little particles are packed in there so tight, they can barely move. Now, what about the water in a stream? You can't just grab a chunk of it, can you? It flows, it splashes, and if you scoop some up in a cup, it takes the exact shape of that cup. Its particles have a bit more freedom, they can kind of slide and glide past each other. And then there's gas, like the air all around us. It doesn't have a shape at all. It just completely fills up whatever space it's in. This room, your house, the whole world. Its particles are zipping around like crazy with tons and tons of space to move. So let's just do a quick recap here. When it comes to shape, a solid is fixed, a liquid takes the shape of its container, and a gas just fills any space available. For size, both solids and liquids have a fixed volume, but a gas, it'll expand to fill any volume you give it. And the big difference is how the particles move. Solids just vibrate, liquids slide past each other, and gases move all over the place. Awesome. So now that you've got a handle on the states of matter, let's see what happens when they start interacting. Because, out in the real world, you hardly ever find things all by themselves. Most of the time, they're all mixed together. A mixture is kind of like a bag of trail mix. You've got your nuts, you've got your raisins, maybe some chocolate chips. They're all in the bag together. But you can still totally see all the different bits. And you could, if you really wanted to, pick them all out and separate them again. But a solution, well, that's a whole different story. It's a really special kind of mixture where one thing just seems to vanish into the other. Like when you stir sugar into a glass of water. After a second, you can't even see the sugar anymore, can you? It's dissolved, creating a solution.
And there's a simple recipe for this, once you know the lingo. You start with your solvent. That's the liquid part, the thing that does the dissolving. Then you add the solute. That's the stuff that's going to dissolve. The solute dissolves, and bam, you've made a solution. Just remember those three words: solvent, solute, and solution.
Okay, Explorer, you are getting seriously good at this. You can tell all sorts of substances apart. So now we're going to use that same skill on your mission briefings. I'm talking about your exam questions. They are packed with action words. They're like secret codes that tell you exactly what to do. So let's crack them. Think of these words as your direct orders. When you see a remember word, like define or identify, it's pretty simple. It's just asking you to state a fact you've memorized. But then you get understand words, like explain or summarize. These want you to go a little deeper, to show you really get why something happens. And the top tier ones, the analyze words, well, that's where you get to connect different ideas and really show them what you know. Now, there is one code word that is so important, so absolutely critical for your missions, that it gets its very own spotlight. And that word is compare. Listen up, because this is huge. Whenever a question asks you to compare two things, it is always a two-part mission. You absolutely must talk about how they are similar, and you must talk about how they are different. If you only talk about their differences, you've only done half the job. I'm going to say it again, similarities and differences. Every time. We're in the home stretch now. You understand the landscape of matter, and you know how to decode your mission objectives. So the very last skill any top scientist needs is documenting your discoveries. And in science, that means clear, precise drawings. And hey, don't worry, this isn't about being a great artist. Not at all. A good scientific drawing is simply a clear, accurate record of something you saw. It's a super important tool that lets us share our knowledge with other scientists, so it has to be done the right way. And there are rules, but they're simple, just 5 of them. 1. Always use a pencil and give your drawing a title with a line under it. 2. Draw a perfectly straight vertical line, a guideline, on the right side for your labels. 3. Draw straight horizontal lines from what you're labeling over to that guideline. Use a ruler. 4. Write your labels neatly, and, this is a big one, your label lines must never, ever cross. And 5. Absolutely no coloring or shading. We want it clean and clear. These rules make sure any scientist anywhere in the world can understand exactly what you observed. And that's it. Your science exam field guide is complete. You are fully equipped. You know your matter, you can crack your mission codes, and you can document what you find like a professional. The entire world of science is just waiting for you. So my only question is, what new discoveries are you going to make? Now go explore.